Hey everyone, Sanjay Medichurla here. I'm here with homework 3 of my computational methods course. And so basically, this is about variable transformations for a chemical engineering application, right? So suppose, like, a lot of times we'll have mole fractions, right, for a mixture. And those mole fractions must be constrained between 0 and 1. And so that's kind of a problem for us because sometimes when we want to run minimizations, maximizations, optimizations, things like that, we have to enforce that constraint, which can be tough to deal with, right? Um, and so a convenient way to overcome this is by the following variable transformations, right? Um, and what we're going to do in this video is solve for VI in terms of mole fractions and get an unconstrained variable transformation that we can work with and get the mole fractions from. So if we get VI, we can modify that variable however we want to, and it will get us the correct mole fractions. So let's get started, right? So we have the expression, or let me get my brush ready. Let's do this thing. And this one's a lot easier than you think. So we have an expression, right? Xi equals e to the power of vi divided by 1 plus summation e to the vi. And so the natural thing, get it, is to take the natural log of both sides, right? So what we're going to do is, um, okay, yeah, there you go. ln xi equals, so we can take the ln of the top minus ln of the bottom because of log rules, um, which tell us that ln of something division, you can just subtract them, right? So the ln of the top, e to the vi, is just going to be vi, and then the ln of the bottom, so you get minus ln 1 plus summation e to the vi. And we can't do anything else with that right now. But we can look at that second expression, right? So you have, and this summation should be I equals 1 to n minus 1. And then so you have this summation, x sub n equals 1 plus summation I equals 1 n minus 1 x sub I, right? And so the natural thing, right? What we should do is we have an expression for x sub I given, and so we can just substitute that into the x sub n equation, right? And so you get x sub n equals 1 minus the summation, and I'm going to stop writing the bounds. The bounds aren't changing. 1 minus the summation of e to the vi over 1 plus summation e to the vi, right? And then so how do we simplify this? So the only things that we care about in a summation are what we're actually summing, right? So what's actually changing. So the denominator here is a constant, right? It's a constant because the summation of e to the vi is a number, 1 is a number. So we can pull that out. So I'm going to subtract 1 over and multiply by negative 1, which makes me get 1 minus x sub n, um, excuse me, equals, and I'm going to take this out, times the summation e to the vi. I realize I started writing slanted here for no reason. Um, uh-huh. And then I'm going to, so you can just multiply this over. So we'll scroll down a bit, right? And then I'm going to say 1 minus x to the n times, 1. Well, now I know why I'm writing slanted. I'm not using actual lines. Equals the summation of e to the vi. Right, and then let's distribute. So you get 1 minus, it's just foiling, 1 minus x sub n plus summation e to the vi minus x sub n summation e to the vi equals summation e to the vi. So these terms cancel, right? And essentially, what you're going to get here, you'll get 1 minus x sub n over x sub n equals the summation of e to the vi. Now, we can go back. We can go back to our original expression and plug that in for the summation of we can plug that in for the summation of e to the vi. So let's go down. So natural log x sub I equals vi plus natural log of 1 plus 1 minus x to the n over x to the n. Yeah? Um, and then we can, so first thing we can do is turn this into ln of 1 over x over n, x sub n, because that's just a quick variable. Like you just make a common denominator, add the fraction over, and then you subtract the fractions to isolate v sub I. So v sub I equals ln xi minus ln 1 over xn. And then we combine with log properties, and you get ln of x sub I over x sub n equals vi. So basically what that tells you is your variable transformation, you'll take the natural log of the mole fraction of that component divided by the mole fraction of the last component, and you can use that for unconstrained variable transformations for mole fractions. Thank you guys for watching, and I hope you learned something. Thanks. Bye-bye.